Hello everyone. Through this video we will continue our chapter number 7, that is ratio and proportion. In the previous video we have discussed about the term ratio. Now let us talk about proportion. Four non-zero quantities A, B, C and D are said to be in proportion if A is to B is equals to C is to D. Means we can say that the four quantities are in proportion if the ratio between A and B is equals to the ratio between C and D, where A is the first term, B is the second term, C is the third term and D is the fourth term. And the proportion can be expressed as A is to B proportional to C is to D, where this is the sign of proportionality, and we can read it as A is to B as C is to D. Now we have another formula. When four quantities are in proportion, then we can write A is to B is equals to C is to D, where the first and fourth term are known as extremes or the AND terms, and B and C are known as means or middle term. Then we have the formula product of extremes is equals to product of means. A into D is equals to C into B. Now the next topic is continued proportion. Three non-zero quantities of the same kind and in the same unit are said to be in continued proportion if the ratio of the first to the second is the same as the ratio of the second to the third. Means when we have three non-zero quantities, then they are said to be in continued proportion if the ratio between the first and the second term, that is A is to B, is equals to the ratio between the second and the third term, that is B is to C, where B is called mean proportion and C is called the third proportion. Now let us take some questions of exercise 7b to understand more about this topic. Here I am taking question number 7, first part. If A, B, C are in continued proportion, show that A square plus B square upon B, A plus C is equals to B, A plus C upon B square plus C square. So as given in the question, A, B and C are in continued proportion. So we can write A upon B is equals to B upon C. After solving this, we will get B square is equals to AC. Now in order to show, we have to take A square plus B square into B square plus C square. When we cross multiply it, then we will get A square plus B square multiply B square plus C square. Now in this we will put the value of B square, which is equals to AC here. Now from both the bracket we can take A common from the first bracket and C common from the second bracket. So after taking out common, we have A in the first bracket A plus C, then C in the second bracket A plus C. Now when we again solve it, then we will get AC and A plus C multiplied by A plus C, then we will get A plus C whole square. Then here the value of AC is equals to B square, put it here. So it will be B square in the bracket A plus C whole square. So we can write it as B A plus C in bracket whole square. So when we factorize it, then it will be equals to, in one bracket we have B A plus C and in another bracket also we have B A plus C. Now when we take B A plus C to the other side of equals to, and this b square plus c square to the other side of equals to, then we will get a square plus b square upon b a plus c is equals to b a plus c upon b square plus c square, which we have to prove in the question. Now the next question is question number 12. If y is the mean proportion between x and z, prove that x square minus y square plus z square upon x raised to the power minus 2 minus y raised to the power minus 2 plus z raised to the power minus 2, which is equals to y raised to the power 4. So as we have given in the question, y is a mean proportion between x and z, so we can write it as x upon y is equals to y upon z. When we will solve, then we will get y square is equals to xy. Now take LHS. So we have x square minus y square plus z square upon x raised to the power minus 2 minus y raised to the power minus 2 plus z raised to the power minus 2. Now the numerator remain as it is, and in denominator, to make the power positive, we have to take the reciprocal. So it will become 1 upon x square minus 1 upon y square plus 1 upon z square. Now again here we have to put the value of y square, which is equals to xz. So put it here, value of y square xz, and the next term remain as it is. So it will be equals to x square minus xz plus z square upon 1 upon x square minus 1 upon xz plus 1 upon z square. Now take the LCM and solve it. So when we take the LCM here, then we will get the LCM x square z square. So here when we solve it, then we will get z square minus xz plus x square. Now again when we solve, then this x square and z square goes into the numerator and multiply by x square minus xz plus z square in this way. So we will see here this x square minus xz plus z square is cancelled by z square minus xz plus x square. Then we have x square and multiply by z square remaining here, which can be written as xz whole square, and we know that the value of xz is y square, so put it here. Now when we solve it again, then we will get y raised to the power 4, which is equals to RHS. Next question is question number 14. Find two terms such that the mean proportion between them is 12 and the third proportion to them is 96. So let the two numbers be x and y whose mean proportion is 12, which is given in the question. So x is to 12 as 12 is to y. Now x upon 12 is equals to 12 upon y. When we solve it, then we will get xy is equals to 12 whole square. Now xy is equals to 12 12s are 144. From here we will get the value of y, which is equals to 144 upon x, which we will use further in this question. So take it as the first equation. Now in the question we have given the third proportion to these two numbers is 96. So the third proportion is 96. So we can write x is to y as y is to 96. Now we can write x upon y is equals to y upon 96. After solving this, we will get y square is equals to 96x. Now from the first equation, we have the value of y is equals to 144 upon x. So put it here, the value of y 144 upon x whole square, which is equals to 96x. Now it can be written as 144 into 144 upon x square, which is equals to 96x. Now when we take this 96 to the other side of equals to, then it will become 144 into 144 upon 96 is equals to x square into x. Now further when we solve, then we will get, it is cancelled by the table of 12 8 times and it is 12 times, again by the table of 4 2 times and it is 3 times, it is by the table of 2 72 times. Then 72 into 3 we will get 216 is equals to x cube. Then we know that the cube root of 216 is 6. Then this is the value of x, which is the first number. Now in order to find the second number, we have the value y is equals to 144 upon x. So put it in that value. So 144 upon 6, when we solve it, then we will get the value of y, which is equals to 24. And these two are our required numbers.